Welcome back to Vex Isn't Scary. This is part 5, and we're going over loop conditionals. So we have the for loop, the for each, and the while loop. For each, and while all have something in common in that they are loops. They run multiple times depending on a conditional. You can almost think of an if statement that runs as long as its condition is true. So in Houdini, we can go ahead and create a geometry node. We can rename this to part 5 loops, and then dive inside. Let's just create an attribute wrangle by typing AW. And what we're going to do is we're going to set this to detail. So we haven't really covered this properly in the past, but basically when you're running over detail, you don't need a geometry. What it's doing is it's creating all of your attributes as a general description. So it doesn't apply to any geometry in particular, but if we were to add geometry, that detail would still exist. So basically, it's an attribute that is independent of the geometry. So we can use this just to visualize things in our geometry spreadsheet. It'll appear over here in the geometry spreadsheet under the detail attributes. So they'll show up over here. In here, we're going to press Alt+E to bring this up. So before we get into loops, we need to tackle a new data type. This is the array. An array is a list of values of a certain data type. You can have a list of floats, or a list of strings, or vectors, or integers. Each entry in an array is known as a component. Each component is found at a certain index. For example, in an array of integers 4, 8, 3, 2, and 9, there are 5 components. Each component has an index. For example, where the component is equal to 8, in our example, the index is 1. Remember, in coding we start counting from 0, so index 1 is actually entry number 2. An array can have anywhere from 0 to near infinite components. And to create an array, we use the square bracket syntax. This lets Houdini know that we want an array. For an array variable, we do the following. Let's create an array of floats. Float my array. Now, this just looks like a normal float, but remember we mentioned the square bracket syntax. So after the variable name, you put 2 square brackets. And then you say equals, and in curly braces, you can give it some components. 0, 2.1, 5, 9.3, 8, right? And then semicolon right at the end. So this is an array. As you can see, it has multiple components. In the next line, I'm going to show you how to fetch a single value from a certain index. So let us create a test attribute so that we can see what it's actually assigning as a value. So we say @test, and now we know that that will show up in our geometry spreadsheet, equals my array, and then in your square brackets, you put the index number that you want. So if I put in here 2, and then semicolon at the end, we're expecting 0, 1, 2, we're expecting the value of 5. So if we apply and accept, then go to our geometry spreadsheet, that's exactly what we have. Our test attribute is equal to 5, which is the value at index number 2. Cool. So Alt+E, bring this back up. Now, what happens if we wanted this entire array as an attribute? We could also do that. This one, you give the data type, and then you give 2 square braces, and then you give it the name. So @test array equals, and then you just say my array. And you only use the square bracket syntax when you're initializing and when you're calling a certain index number. Over here, we don't need to use the square bracket syntax because we're not calling a particular index. So we have float array called test array, and we make it equal to my array. Apply, go over to geometry spreadsheet, and there we have it. 0, 2.1, 5, 9.3, 8, the exact same thing as my array. Great. So let's make some changes to these arrays. We can remove this @test equals my array, but we'll keep the array attribute. Here I want to show you how to change individual array components. So we say my array, and then you give it the index number, so say 3, is equal to, and then you give it a new value, so 6. And we can put a space over there, a space over there. And what this should do is change index number 3 to a value of 6. So 0, 1, 2, 3, 9.3 should become 6. And if we apply, go to our geometry spreadsheet, 9.3 is now 6. We can also add things to our array. If we say something like my array, and you give a value that is outside of the bounds of this array, this one has 0, 1, 2, 3, 4 components. So if we put 5 in here, and then we make it equal to 12, and apply, you'll see that it adds it to the end. But if we do something like my array 8 equals 3.2 or something, and then apply, it fills all of the indices between these two with zeros. So that's just the basics of arrays. Now, you may be thinking, why am I spending so much time on arrays in a loop tutorial? That's because the first loop that we're going over is the for each loop. And the for each loop is meant for running over arrays. We're going to remove everything over here except this float my array variable because we can work with it. Let's create another variable called float sum of array, and we'll make it equal to 0. Next, we can say for each as one word, float array value. Then we put a semicolon, and that may look a bit weird because we haven't done that before, where you put a semicolon in the middle of a condition, but I'll come back to that shortly. And then the array to check, my array. And then in here, we can do some code. What is this doing? Well, for each is a keyword. Now, this takes 2 arguments. I'm going to cover the second argument first. The second argument, you may notice, is our array. That's this my array variable. We're putting it here as our second argument. And then it's saying for each of the components of my array, right? So for each of the components of my array, put it into this float called array value. So what that means is it'll run through each of the components in our array, assign it to array value, and then we can use array value inside of our for each loop. So we can say something like sum of array plus equals. So what that does is it adds something to our existing variable. So it adds something to sum of array. So we say sum of array plus equals array value, semicolon. What this should do is it should take each component in this array and add it to sum of array. So sum of array will be 0, then it will add 0, so it will stay 0. Then it'll add 2.1, so it'll be 2.1, then it'll add 5 to 7.1, and then 9.3 to 16.4, and then 8 to 24.4. Well, my math might have fallen apart, but I'm not sure. Anyways, apply and go to geometry spreadsheet. And of course, we need to turn this into an attribute if we want to see it. So we can say at sum equals sum of array. Apply, and there you have it, 24.4. Cool. So that's how you use a for each loop. And that's useful because, for example, if you wanted to find all of the neighbors of a point and then share an attribute to them, you would put all of those point numbers into an array, and then you would say for each neighbor, maybe like infect those points or give them a value, something like that, right? You want an array of something, and you want to check how many things are in that array, but you might not know how many things are in that array. So you could use a for each to check everything in that array. So that's our for each loop done. And I hope that you can see that that's quite basic, right? All it does is it fetches things from an array, puts it into this float, and then we can work with it inside. Now, for loops are a bit different. For loops have 3 arguments. The variable in the brackets is an iteration count, rather than the value of an array or anything like that. Every time the loop runs, the iteration counter goes up until it causes the condition to be false. Then the for loop stops running. For loops run for a certain number of times. They have 3 components to their condition. The first part is variable initialization. The second is the conditional. The third part is the iteration. You can think of it as controlling the start, during, and end of the loop. So I'm sure that sounds a little bit complicated, but let's just create a for loop, and you can see exactly what I mean. We can create another attribute wrangle to the side over here, set it to detail once again, and let's actually rename these in case you want to keep this file for reference. So we can have for each and for. So in our for attribute wrangle, we're going to do a bit of a test. We're going to do int sum, and we're going to make that equal to 0. We're going to make an integer called number of iterations, and make that equal to a channel integer. We covered this in the last tutorial, chi plus a name. So we'll just call it iterations. And we can create that salon, right? So we just have this iteration over here. We can choose how many iterations we want. Let's press Alt plus E to bring this up, because now we're going to get into the for loop. So here we go. For, open brackets. We'll also do our curly braces over there, and we can fill in our 3 arguments. Firstly, we have an iteration variable that we need to initialize. So we say int iteration equals 0, semicolon, iteration less than number of iterations, semicolon, iteration plus plus. Okay, what is happening here? What we're doing is we're creating an iteration counter, right? So this could also be called something like iteration counter if you wanted, right? It's just a variable that you can create. So iteration equals 0. We're initializing it as 0. Then we're saying, as long as this value over here is less than our number of iterations, so this value over here, this variable, then run the code. And when you finish running the code, increase our iteration number. So we say plus plus, that just means increment by 1. So add 1 to it. It's the same as saying plus equals 1, right? So we say plus plus. And so let's get an exact feel for what this does. So in here, we could say something like sum plus equals 2. So what this should do is every time it runs, it should add 2 to our sum. And then what we can do is afterwards just say at sum equals sum, right? So we're making an attribute named after this variable over here. And if you want to make it more clear, you can say sum attribute, so that we know that this one's the variable, this one's the attribute. Apply and accept. Go over to our geometry spreadsheet. And before we go over, what do you think the value is going to be? Keep in mind our number of iterations is set to 0. And if you said 0, you would be correct, because this hasn't even run, right? If iterations are 0, then we enter our for loop. It says iteration equals 0. If iteration is less than the number of iterations, run this code. But it doesn't get there because iteration is not less than 0, right? 0 is not less than 0. So it won't even run this. But if we increase this to 1, you'll see our sum attribute goes up to 2. And as we push this up, this for loop will run that number of times. It'll run 8 times and add 2 to sum 8 times, right? It's the equivalent of saying this. Int iteration equals 0. If iteration is less than 8, run this code and then increment iteration up. So this middle one is almost like an if statement, right? It actually is an if statement. It's running an if statement every single time. It's saying if this is met, run the code, and then increase iteration. One thing to note is that in almost every coding language, we don't use int iteration, we'll do something like int I. Int I is almost always used, right? It's one of those things that coders don't even know why it's there. It's just int I. And it's most likely because it was originally called iteration. And so you would use something like that, right? And over there as well. And we can switch this back to number of iterations. So I equals 0, I is less than the number of iterations, I plus plus, then do this code. All pretty cool. And if you wanted another for loop inside of here, you would have to use a different variable name. You would have to make it something like int j. Generally, it goes I, j, k, right? And then if you happen to be using so many for loops, you'll just keep following the alphabet, L, M, N, whatever. So let's go back to our scene view. And let's go over the last type of loop. Create another attribute wrangle, set it to detail, and call this one while. So while loops are like for loops, but without that iteration counter. Instead, they run until the condition is no longer true, which means they're literally just if statements that keep running. Right? An if statement would usually just check, say, if a point is above 0 on the y-axis, and then make it blue. But a while loop will check while a point is above 0 on the y-axis, run this code and make it blue. So it will keep trying to make that point blue, right? And I can show you this, and it will maybe crash Houdini because we're about to enter into an infinite loop. So bear with me. I don't even know if this recording will keep going. Hopefully it will, and I can just escape this. But if you say something like while 1, then at test equals 5, right? Okay, so I'm going to click away and see what this does. And there it goes. It's starting to run this code infinitely. And fortunately, Houdini hasn't crashed, and I can press escape to get out of it. But you just saw, if nothing makes my while loop leave this while loop, it will keep doing this. This is a bit of a weird one to use, and it's quite easy to break your code with it, but it's also very useful. So let's press Alt-E to bring this up. And while loops are honestly the most simple of all the loops. It's just a condition. While do this. So while this is true, do something. So let's create a variable to work with here. And let's just call this int trueCheck equals 0. And then we can say float test value equals 0. And then over here we can say while trueCheck equals 0, do the following. Then we can make test value plus equal 10. Now, I'm not going to apply an except because that's going to send us into an infinite loop. Can you see why? It's because trueCheck's value is never changing. So what we could do in here is we could rather say if test value is greater than 1000, and then we put our 2 curly braces, then make trueCheck equal 1, right? So now maybe you can see the logic behind this. What we're saying is, while trueCheck is equal to 0, increase our test value by 10. And when this test value gets greater than 1000, set trueCheck to 1. And then because trueCheck is 1, this will no longer be true, and it'll leave the while loop, right? So it's just a logic thing. While this is true, keep increasing this value. When this value reaches a certain point, make this false. So we apply an except, and we can also add a check at the end of this. So we can say at check test equals trueCheck, and we can also say at value test equals test value. Okay, this is a bit of a weird naming convention that I've chosen. Don't be like me. Be better than me. But anyways, if we go to our geometry spreadsheet, you'll see it says check test 1, right? Because this trueCheck became 1 after this reached 1000. And the value test is 1010. Basically, it's just because we've only said if it's greater than. So only once it's greater than will stop. If we say greater than or equal to, then it should, so it should set it to 1000. The more you work with it, the more it makes sense. So I encourage you to play around with it, just putting in random values and seeing what you get. If you break anything, cool, that's a great way to learn. But yeah, just mess around with these. And what you would usually do with this is something like an infection solver. So I'm not sure how long this tutorial has been going on for, but I think it's getting kind of long. So if you don't want to watch this part, it's cool. You can skip ahead. There's no more new information here, really. I'm just going to be using some functions that you may not have seen. But if you want to follow along, I'm just going to show you what you can do with a for each loop, for example. So let's create an attribute wrangle over here to the side. We won't be using detail this time. We'll run it over points. Let us create a grid and scatter some points on it. So now we just have this grid over here, bunch of points, and for some reason my points are small again. Display geometry up to 10, save as default. Cool. So big points. Now plug that into our attribute wrangle. The other thing that I want to do is use an add node to add a point. What this does is we can just add a point at the origin, right? Cool. Little point over there. We can move them around if we switch on our transform handles. So we can move it over there rather. And you can see its position over here. We're going to drop an attribute wrangle. And in here, we're going to give it a value. We're going to say at infected equals 1. So this little point is now infected. right? If you go over to point attributes, this point over here, point number 0, is infected. And infected is just an attribute I came up with, right? You can call it whatever you want. Next, we merge it in with the other scattered points. And then we feed that into our attribute wrangle. So we have this now. Now if you check your geometry spreadsheet, only one point is infected. All the points coming in from the scatter grid get a default value of 0. That's also why we have that little warning over there on the merge, because there's a mismatch of attributes, and so it defaults a whole bunch of them to 0. The fix to that would be to add an attribute wrangle to your scatter as well, where you say infected equals 0. And now both sides have the same attribute, so that error goes away. Like, it's not a big deal. You know, maybe it's bad coding practice, but I do it all the time. Next, we go over to our attribute wrangle, and this is where we're going to start using what we just learned. Here I'm just going to press Alt+E, bring this up, as we usually do. So what I want to do here is I want to search around any infected point for some other points and infect those points. So what would that need? Well, it would need a radius from that point that's infected to search for other points, and it would need a number of points that it's allowed to infect, right? So, you know, those are the two basic parts of it. You would say int number of points, right? So that would be the number of points to infect. You can even call it that. Actually, I'm not. That's just really long. Equals chi. In here, we say number underscore of underscore points. Next, we also say float radius equals chf radius. And you can even call it search underscore radius. That's probably a better name. Semicolon at the end. So we have two channel parameters now. Apply, accept, create those. Alt+E to bring this back up. Now, we also need to store those points that we find, right? So what is a great way to store a bunch of point numbers? Aha! We can create an integer array. So we say int neighbor point numbers, square brackets, because we want an array, equals near points. And this is a function that I haven't shown you before. It's a bit more of a complicated function. It has quite a few components to it. To check what components it has, you can press space and then backspace, and it'll bring this up. So you can see that it says finds all the closest points in a geometry. So we have geometry, vector pt, float max dist. Now, I've used this a lot, so I know what these mean. Firstly, you need the geometry stream, which is geohandle 0. You then need a position to search around, which is at position, so at p, right? We're searching around the current point. Then we're saying, in what radius should I be searching? So we put radius over here. And then we also say, how many points do we want? So this one, we put number of points. And we can apply and accept, and there's no errors. So cool, we can continue. Then we want to say, for each of the neighbors that we have found, do something, right? So in here, we want to say, for each int pt, semicolon, neighbor point numbers. And in here, we're going to say set point attrib. This is another function that I haven't shown you yet. And in here, we need a geohandle, and then the attribute that we want to change. So that would be infected. And then we need the point number, which is pt. So we're fetching pt from our neighbor point numbers. And then the value to give it. So it would be 1 because we want to infect them, comma. And then in inverted commas, you say set. Now, this is just a thing that tells it to set it. I'm not entirely sure what the other options are. I almost always use set. But this is set point attrib, right? The geometry handle that we're checking points in, the attribute that we want to change, the point number that we want to change the attribute for, the value that we want to set this attribute to, and we just tell it that we want to set. Now, the issue with this is that it'll work, but every point will be infected. I can show you this. If you apply and accept, and then increase search radius up to 0.5, a number of points up to 5, if we go to our geometry spreadsheet, everything's infected, right? The reason is we don't actually have anything that's checking to see if the point is firstly infected to infect its neighbors. So we just press Alt-E to bring this back up. And we can just say if at infected equals 1, then do all of the stuff. So we'll just wrap all of these things in here with curly braces, click and drag over all of this, and you can press tab to indent it, or you can use this over here. That's just indents as well. So now it will only run this section of code if the currently processed point has an infected attribute that equals 1. So if we apply an except to visualize this, we can drop down a color node, and we can just go over here and say ramp from attribute, and the attribute that we want to ramp for is infected. And so the colors, you can just make them red and black. And as you can see, it infects some points. Now you'll notice that only 4 points are actually being infected, right? 1, 2, 3, 4, and then this one over here is the original infected point. But we've said infect 5 points. The reason it's doing this is because it adds itself as a neighbor. And that's simply because near points uses a position. So any point that's around this position gets included, including itself. So we can just fix that by pushing your number of points up by +1 to include itself. And then if you increase this number of points, you can see that it gets limited by the search radius. But if you increase your search radius, it increases the number of infected points. So that's pretty cool, because that also means that you could even put this into a solver. And this is something we'll be doing in a future tutorial. We're going to be creating custom solvers. So let's create a solver node, type solver, drop that down, and Control and X to cut your attribute wrangle. Put this right over here. Dive inside of your solver. Paste your attribute wrangle with Control+V. Plug your previous frame, so this purple node, into your attribute wrangle. Set the display flag on the wrangle. Jump up. And if you play this back, everything gets infected over time. And so you can change the values on here so it infects fewer points, maybe only 7 in a smaller radius. Play that back. And that's pretty cool. That also means that it works on any geometry. So you can put a rubber toy in here. And if you bring that point a bit closer, it will infect our rubber toy. And you can give this rubber toy more points, so 50,000. And this still works. If you go into your solver, we can now decrease the search radius maybe. And if you play this back, you have an infection solver. And you can do all sorts of things with an infection solver. Like you can use this to create velocities so that all of these points fly away. Or, you could even do something. Let's try something like this. If at infected equals 1, then v at p plus equals v at n. What that'll do is it'll push it away by the normals, and we can multiply that by a smaller value, 0.1, maybe a bit more, 0.5. So now as it infects, those points get pushed out. And you just end up with this fat rubber toy. Anyways, it's pretty cool that you can make a infection solver with just a basic for each loop. It's nothing too crazy. All it's doing is using some functions and your for each loop. You don't have to worry about this too much. This was just a bit of a bonus thing. This is what you really want to focus on, and we'll be going over these again. We'll keep using them in tutorials, so don't worry about it too much. Anything that you don't understand, you will eventually get. It just takes a bit of repetition. So, thank you for watching. Thank you for supporting us. I hope that everyone's enjoying the series so far. I'm enjoying making it. I really enjoy this Houdini's and Scary series. It's a lot of fun to make, and people seem to really appreciate it. So, thank you for all of your support. We will be having a more advanced tutorial as well, a bit later this month, just for everyone who isn't really interested in the beginner stuff or the introductory stuff. So stay tuned for that. And I'll see you next time with part 6. Bye.